Hey everybody, welcome. Welcome to our weekly show on anything to do with AWS networking, the routing loop. We're still in the Chalk Talk season. So we are running our highest scoring Chalk Talks from reInvent 2025. So today we have one of those Chalk Talks with Nico and Luca. It's going to be a Chalk Talk on Lattice. But I'll let Nico and Luca do quick introductions of who they are, where they're from. I think Nico and I actually go way back. We used to work way back when in London for an internet service provider up there. So it's been a while. So it's nice to see
Uh,
him in AWS.
if you remember, you referred me into AWS, so
Yeah.
you still owe me that drink.
I don't regret it. I don't regret it.
Okay, I'm glad to hear.
Okay, so cool.
All
Nico,
right.
you want to do a quick intro? Where you based, and then what's your role is?
Yeah. So, good evening, everyone. I'm Nico. I'm a solutions architect here in the UK. I'm talking to you from London. I work in the ISV segment. And Luca.
Yeah. Hi, good evening or good morning, depending on where you are today. My name is Luca. I'm solutions architect working with software vendors in EMEA, based out of Munich, and looking forward to our chat today.
And you're currently in Berlin. We were just talking earlier about the cool warehouse vibe that you're in, but apparently it wasn't used for raves, from what I'm understanding.
Right. I think it was.
Cool. Well,
I can tell from the bricks.
Yeah. I thank you guys for staying up so late and presenting at such a late hour. Hopefully you won't get kicked out of any of the rooms you're in by the cleaners. I'll bring up the deck and I'll let you kick off. And then folks on the chat, if you have questions, jump in, ask us questions, dig in.
All right. Thanks, Tom. Before we get started, I wanted to really go through what we are going to cover today. Hopefully we'll get as many questions as possible. And remember, Chalk Talk is supposed to be something very interactive and hopefully fun. But I think we need to level set on a few things before we dive kind of deeper into the questions and hopefully the answers. So one of the things that by talking to customers, we find it's very important to clarify is the distinction and the difference between consumers and producers. And very simply put, a consumer is someone that needs to access something else, and a producer is someone that is trying to make something available to others. And whilst this distinction might sound a bit trivial or unnecessary, we find that sometimes it causes a bit of confusion. So let's keep that in mind for the rest of our chat today. Then we'll start with PrivateLink, because if we remember the reason why we're here. We're here about to talk about accessing VPC resources with PrivateLink and VPC Lattice. And VPC Lattice, since December 2024, made this a little bit easier. But let's not forget that this was possible before VPC Lattice, introduced support for VPC resources. So Luca will cover that. Then we will dive a bit deeper into VPC resource access for VPC Lattice. So we'll explain how Lattice allows you to access resources. And we'll also define what a resource is and what a service is, because also this distinction is quite important. Luca, all yours.
So this hopefully is familiar to most of you. What you're seeing right here is PrivateLink, a way to connect to services and other VPCs via these network interfaces in the local VPC. So typically you have on the left-hand side here a service producer, and on the right-hand side you see the service consumer. And the service producer deploys an NAB, then registers their service as a target, and the consumer deploys the VPC endpoints and sends traffic through those endpoints, right? So those interface endpoints, those just get ENIs with IPs from the local CIDR range. And you might know that there's this known restriction that this is unidirectional. So the producer can't initiate traffic to the consumer, only the other way around. But now the service could also be something like a resource, right? So it doesn't have to be, your web shop or whatever an ISV offers. It can also be a database. because it's TCP and NAB does layer 4, right? So, but now you have this network load balancer in front of a database, and you don't really need it, right? That's not ideal. And what if the consumer needs to access more resources? You need more private link connections, you need more network load balancers. Kind of comes with operational overhead and also cost, of course. You're paying for all those endpoints, paying for all those NIBs. It's really not ideal, and that's why we're looking at options to do this in a better way.
Yeah. So the way to think about it, I would say, is it would be to kind of individual application would be its own private link service or VPC endpoint service, right? With this model.
Correct. So theoretically, the NIB can send traffic to different services if you use different ports, right? But then the application, like the consumer, needs to know what port to send traffic to, and I know that's not your normal use case.
Yeah. And then, so why would you? So still sticking to this model, but why would customers go with PrivateLink and VPC endpoints over just peering those VPCs or connecting them using some other mechanism like transit gateway?
Yeah. So the main benefit is that silo clashes are not an issue anymore. So here in this example, also we have 10.1.0.0/16 for both consumer and producer VPC. So that is sort of circumvented by using PrivateLink. You don't need any routing between the VPCs in the first place. And simplicity also, it's a very clean solution and doesn't open up the VPCs to each other, right? Which is sometimes a security risk. It's very targeted. You only get access to this one service that should be exposed.
Yeah, I always like to think about the PrivateLink as like the long arm of the network load balancer extending into another VPC with the listener. So if I'm listening on port 80, that is going to show up on that interface endpoint if I'm listening on 443 and so on. But just to bring back the point, I think this model, single application, usually means a separate NLB, separate endpoint service, separate set of endpoints. So Karim, you're spot on there. Cool.
All right, then let's move on and introduce VPC Lattice, right?
Yeah, so let's park the resource access for a minute, and we need to kind of level set on the terminology of VPC Lattice before we explain how Lattice makes resource access simpler. So VPC Lattice is a service that we introduced a few years ago, and it's made of essentially two components. It's a fully managed control plane and a fully managed data plane that essentially allows you to create combinations of services and resources, and we'll define what a resource and a service is, between different VPCs. And one of the main concepts of VPC Lattice is a service network. And a service network is nothing but a container that can contain services and resources. And as you can see here in this diagram, I have 3 service networks, and each of these service networks contains a different combination of services and resources. For example, on the left-hand side, I have service network A that has service 1, service 2, and resource config X. But service network C doesn't have any resources and only has services 2, 4, 5, and 7. An important property of this model is to understand how a consumer in any of these VPCs, A, B, or C, can access services and resources placed in those service networks. And this is by deploying or actually creating what we call a service network association. And this is basically saying, hey, consumer in VPC A, because we have this service network association, you can access these things that you have in service network A. Now, an important limitation of this is that you can associate only one service network to a given VPC. You cannot associate more than one. And if you want to stick to this model and you want to use more or make more services and resources available to VPC A, you have to place them in service network A. You cannot just associate another service network. And the features that we announced in December 2024 overcome this limitation, as we will see in just a minute.
Just to touch on the way to think about the service network, would that be as kind of a registry of all of the application that want to expose to a particular VPC, right? So it's more of like a container of those services and resources, right?
Exactly. It's a nice way to kind of define very clearly what a certain consumer has access to. It's a very nice, also very nice security property, I think.
Got it. Yeah, I think that whole even auditing point of view, where I can go and see, okay, VPC-A, what are the application of exposed to VPC-A, and all I have to do is go to service network A and look at all of the things in that service network, right?
Yeah, exactly. So another very important concept that we introduced in December 2024 is the concept of a resource configuration. So the resource configuration is a construct that defines or represents a resource or a group of resources in the context of these features, right? Let's think about, I don't know, an IP address or a DNS name that represent something in your VPC that you may want to make available to others, like a database, a Kafka cluster, or even like an SSH box, like a jump host. So you would represent that resource using a resource configuration saying, hey, this IP address is my resource, or this DNS name is my resource. And this would be a single resource configuration. And by single, we mean that it's shareable independently. So you can share a single resource configuration. And that only represent one resource, an IP address, a domain name, or an ARN. An ARN is a special type of resource configuration that we use to represent AWS native resources like an RDS database. And as far as I know, correct me if I'm wrong, Tom, as of today, it is the only type of AWS native resource that we can represent with ARN resource configurations.
That's right.
And then you have group resource configurations that you can essentially use to represent a number of child resource configurations. Let's say you have a database cluster made of 3 nodes, and you do not want to share each node independently through Resource Access Manager so other accounts can access that resource. But you just want to group them for simplicity, and this is the way to do it by using a group resource configuration. Think of a database cluster, a Kafka cluster, anything that is made of many things that should be shared as a collective rather than independently.
And those resources, Nico, those are ultimately just TCP things, right? If we look at OSI layers, these are just a bunch of TCP things I'm targeting, whether they're IP addresses, domain names, whether I'm grouping them into a group or sharing individually, or the database. Ultimately, all of it is like a TCP thing defined as a resource, right?
Yeah, exactly. And one thing that, however, I'd also like to clarify or remind everyone is that even HTTP relies on TCP, right? So no one is stopping you from sharing an HTTP API through this model rather than a VPC Lattice service. But if you use this model, you sort of lose all the layer 7 properties of a VPC Lattice service, like auth policies, authorization policies, and other things. So let's not forget that also HTTP relies on TCP.
Yeah, that's true. Yeah, I think it's just like the resource doesn't understand anything in the upper layers. All it's doing is like treating everything as a TCP thing. Are you going to cover kind of the differences between services and resources a little bit, or does it make sense to like do a quick explanation?
No, we weren't planning to, but I think in general, I think a service is something that you create as in VPC Lattice that is well structured, is made of listeners, and I would think of it like almost like an applicational balancer type of thing, where you're defining what your listener is listening to, but it's all layer 7, right? Rather than being layer 4 like a resource.
Yeah. So if the way I guess to think about it would be if I need Lattice to perform some layer 7 functionality on my application, which today is only HTTP or HTTPS, I would want to set it something up as a service. But if I want Lattice to just operate as a TCP proxy or forwarder, I would define whatever I'm giving access to as a resource. Would that be the way?
Yeah, exactly. And with services, you can do things like path-based routing and attribute-based routing that with resources you can't, right? You just send traffic to a specific resource, and that's it.
Yeah. And there's a kind of comment here. I want to pause for a second from Lewis in terms of, I think we can summarize it in both PrivateLink that we touched on at the very beginning, and then the resources. They don't require any other connectivity in the middle, right? You don't need to have NAT gateways, transit gateways, VPN connections, etc., right?
Yeah. In our Chalk Talk at reInvent, we use this analogy to being magicians, right? Making the networking disappear between VPCs. With PrivateLink, you essentially are saying, I need VPC A to talk to VPC B for a specific service or a specific resource. You don't need to configure any type of networking between them. No VPC peering, no transit gateway, no Cloud WAN within the same region. You just create PrivateLink. And this is something, it's a model that especially ISVs or even us, AWS, when we have AWS service VPC interface endpoints that you might have deployed in your VPCs, like for KMS, STS, and God knows how many others we have. I think it's in the order of hundreds. You don't have to use the public IP, right? You don't even have to have an internet gateway in your VPC. It just works internally.
Cool.
Luis, hopefully that explains it.
Yeah, I think that's great. Thanks, Nico.
Luca, run us through everything from the perspective of the producer.
Right. So there are obviously different ways you can connect to resources, and we'll touch those in a minute. But let's start with the producer side. And so the producer is the resource owner. And no matter what way you use to connect to resources, you will need a resource gateway. So the resource gateway is sort of, as the name says, the entry point to the resources. And in most cases, you deploy it in the VPC that also contains those resources, right? Then for each of the resources, you create the resource configs, as Nico explained. And then this resource represents the resource or the group of resources you want to access. And the resource gateway is then the sort of physical thing that gets deployed in your VPC. So it actually gets IP addresses. And we get a lot of questions here. So that's why we wanted to break it down a bit and explain how this works in some detail. So the resource gateway, you will deploy it in one or more AZs or subnets. And in each of those subnets, the resource gateway gets one ENI, so one elastic network interface. And then the resource gateway gets 1 to 62 IPv4 addresses if it's in v4 or dual stack, and you can configure that. So I think this was introduced around October last year. And before that, you only had the option to get 16 IPv4 addresses on each ENI. And this was not configurable. So this is new. Nonetheless, it's an immutable setting. So if you create a gateway and a week later you might need more IP addresses, you can't change it, right? You need to create a new resource gateway and cannot change the setting in the existing one. Now with v6, it's a bit simpler. Since we have so much space in v6, we just throw a /80 at it, and that's sort of a fixed setting. And now you might be wondering, why do I actually need more or less IP addresses on the resource gateway? And the reason is that it sort of defines the way that it scales. So each IP address allows for 55,000 concurrent connections per resource gateway IP and per destination IP, and also port. So it's quite a lot. Just bear in mind that a port is leased for a few minutes after connection ends. So I would suggest to be a bit more generous with IP allocation rather than trying to save every single IP that you can in a VPC.
I guess if you're worried about IPv4 space here, you could probably put the resource gateway into a subnet that's like a throwaway addressing, right? Because the resource gateway can be used to just communicate with things in the local VPC. If you don't need it to route out to on-premise or anywhere else, which you can too as well, I guess you could just put it in a throwaway subnet, maybe overlapping subnet, that's just purely used to make sure it has enough IP addresses locally in that VPC, right? Have you guys seen that pattern?
Yeah. I've helped a customer do exactly that a couple of weeks ago, and we were using secondary CIDR, overlapping with pretty much everything else they had, but it was a very generous and a very chunky secondary CIDR, and yeah, that's what we did.
Yeah, I think it's a good rule of thumb that if you know that something inside of a VPC will not be talking outside of that VPC, that could be a good candidate for like a secondary throwaway overlapping, whatever you want to call it, subnet, right?
Yeah, that's a good point. And I think you touched something important here also, that the target can be also on premises, right? It doesn't have to be within the VPC. If you have private connectivity to your on-premises environment, then you can also connect the resource gateway to services or resources in there.
Got it. And then there's also a call out from Karim here about when he was testing that the source IP of the traffic hitting things inside of that VPC, because we're looking from a perspective of someone exposing a service. So that resource gateway is a way to get access to a service I'm exposing. And then whenever he's testing, he's saying that he saw everything coming from the IP address of the resource gateway, right?
Yeah. And that's also the reason that so you can put security groups on the resource gateway, and you will notice that the inbound rules have no effect. It's actually just looking at the outbound rules and making sure that it allows traffic to the resources that you want to have access to. So for the RDS database, for example, here it just looks like the network interface from the resource gateway is connecting to it. It doesn't actually care what's in the consumer VPC.
Got it. And there's another question here from, actually, we can touch on maybe two more questions here. There's a question about accessing RDS resources. I think it's more kind of asking about how you actually are getting to the database. Would you use a DNS entry and target the database's DNS, or with RDS? I think there's like an ARN reference, right, that we can directly reference a particular service.
If I'm not mistaken, with RDS you get a domain name for the database, at least for the reader, and if you have a reader and a writer endpoint, that get automatically carried across to the consumer if you're sharing an ARN resource. I could be wrong, but
yeah, I think that's correct. You point to but you out of the three different types, right? There's a DNS targeting DNS. I have seen customers also target databases as a DNS name. Like that, in theory, it would still work, because if there's a DNS name and there's a failover, the DNS name gets updated. So that, I guess, would still work. But you can also just target that ARN and just have it native.
Yeah.
There's one more question. I think this might be a good time to touch on it, or maybe you could tell me if we want to pause it and touch on it later. It's related to like adding firewalling services. Right. So it has come up with my customers. I wonder if it came up on your end. It's customers asking, can we put a firewall somewhere in the path? I guess we're looking at the provider side, so maybe that's where we will focus on. Can I put a firewall between the resource gateway and the thing that resource gateway is talking to? I guess that's possible, right? You can route through a firewall, but then my question there is always, like, what is the value that you're getting, right? You're adding something that's going to add 10 milliseconds latency potentially. You're paying for processing. You're paying for, even if it's a third-party vendor or if it's network firewall, you're paying for it doing its work. If you don't do TLS decryption, you're kind of doing layer 4, maybe SNI-based filtering, and then which is already happening by default by you exposing a host name on a particular port. So it's questionable in terms of what is the actual value that you're getting here. I don't know if you've seen the same request from customers on your end.
I think not specifically this question. I think the most similar question that I got was inserting a firewall between on-premises consumers and resources exposed through a service network endpoint, but we haven't gotten that far yet.
Okay.
Yeah.
Okay. Yeah,
I
we
would
can touch
say
on the firewall in there as well, I guess.
Yeah.
Sorry,
I
Luca.
think I've only discussed why and never actually the how, so we never got there. But if you've seen patterns to include a firewall there, please tell us, Tom.
Yeah. There's another question I think that might be good to touch on right now. Authorization rules and IAM permissions. Can you do that on resources similar to services, right? Because I think we haven't touched on services. We probably will not in this session. Just kind of quickly summarize it. But services are those layer 7 constructs where we can do IAM-based identity validation, but it's not supported on resources, right?
Yeah,
correct.
Exactly.
Yeah.
And as I remember in one of the previous episodes, Alex clarified a very important point that seems to cause a bit of confusion with customers, probably because of our own fault, right? The way we explain things. There is this perception that you must SIG-V4 sign all HTTP traffic from the consumer to that service network to use auth policies, but in reality, to use some constructs or some properties of auth policies, you don't have to SIG-V4 sign, right? You have to SIG-V4 sign if you want to inspect on the principal that is making a certain HTTP call. But other things like source VPC and other metadata, you can still do without SIG-V4 signing.
Yeah, but that's all still for services. I think resources we are hearing asks from customers, can you do something on resources? And we hear. So watch this space. All right.
Right. We haven't talked yet about the consumer, right? Luca explained everything from the producer side. And now I would like to cover a bit more the consumer side. So once you've created your resource gateway as a producer in your VPC and you created the resource configurations, what do you have to do as a consumer if you want to access those resources? And in the 3 examples that I'm going to cover now, I actually decided to wrap these VPCs in separate AWS accounts because it's a very, very common use case where you have a producer account or producer VPC, especially if you think Luke and I work with ISVs, so this is very, very common with ISVs. And you have the producer VPC in a producer AWS account, and the consumer that is owned by a separate AWS account can consume those resources, provided that those resources are shared with the consumer. And the approach that I'm describing here is called the PrivateLink approach. And technically, it doesn't follow any of the lattice patterns. It's purely a new type of interface endpoint that we added in December 2024 called the resource VPC endpoint. And essentially what you're doing here is you're sharing a resource configuration from the producer account over to the consumer account. And in the consumer VPC, you're deploying VPC endpoints. And as you can tell here from the diagram, hopefully, is that you have to deploy one VPC endpoint per resource. And I think it's quite evident here that it's an approach that has some scaling limitations, like if you have many resources or if you have many accounts, this can be a bit problematic, right? Because you need to, let's say you have 50 resources, you will have to deploy 50 VPC endpoints and pay for them, right? Because the pricing of these VPC endpoints follow the standard interface endpoint pricing. So you pay both, you have a volume charge and also an hourly charge for those interfaces.
Yeah, I guess we were chatting about it a little bit earlier as well, right? That this is a pattern that we see some customers adopt, usually when they kind of want to keep things very, very simple and not do kind of additional settings with Lattice. But ultimately, Lattice Service Network is probably the more common, more scalable way to do the same, right?
Yeah. And when we had the chat earlier, Luca shared something very interesting about which I also noticed from customers, that whenever this choice is made, it's normally because of fear of the unknown, let's say, because they've never used Lattice, they don't know what Lattice is about, they've heard it's a service mesh, but it really isn't, and they are afraid that it's added complexity. But I think it actually simplifies things if you have more than one or two resources that you need to consume.
Yeah, agreed.
So the second consumption type is what we call the native VPC Lattice approach, that relies on this concept of the Service Network VPC Association that I talked about in the beginning. So let's start from the right-hand side, where you have your producer. Here, nothing has changed. You have your resources, your resource gateway, and you share those resources to an intermediate account. And again, this isn't a requirement. I just drew it up because it's commonplace, right? You have a networking team that wants to manage networking between VPCs, and it happens quite often that they also own the service network. And I will probably can explain a little bit as of the reason why. So the producer shares the resource configurations with the networking account. And because of that, the networking account can create a service network and place those resources inside that service network. Yeah. So the networking team have the ability of creating a number of service networks with a different permutation and combination of resources and services, depending on what the consumer patterns are, right? But let's keep it simple for now. We have only one service network. So the networking team now has to share the service network with a consumer account or any consumer account. It could be even an organization unit or the whole root OU if you're using organizations. And because of that, the consumer account can associate that service network in any of the VPC that the consumer account owns. And only because of that, of the creation of that service network VPC association, the services and the resources contained in that service network will be accessible through some non-routable IPv4 addresses and also IPv6 addresses, link local IPv6 addresses that I omitted to write here. Alex, if you're watching us, I'm really sorry, apologies. Alex is one of our colleagues, and she's one of the biggest advocates of V6. In case you don't know
I
her.
think you're just in the bot box. She's gonna find you.
Yeah, probably. And so Consumer VPC has now a Service Network VPC association, and because of that, any workload in the Consumer VPC can then access those resources through that Service Network VPC association. Everything that I'm saying, I sort of omitted one important detail, which is security groups. Everything that I'm saying is provided that the security groups that you associate to the resource gateway and to the Service Network VPC association allow for that traffic to go through, right? Security groups are honored from left to right.
Yeah, I think that's security groups blocking probably the most common things that you run into when you do your own testing. When something's not working, it's either security groups or you're missing a route. But with Lattice, you don't really need to do routing, so it's usually security groups somewhere.
Yeah. Well, you can use GenAI these days to help you out, right?
Yeah, I heard the DevOps agent is pretty good at troubleshooting your environment.
And the last consumption pattern is the service network endpoint pattern. And before we dive into that, and let's actually go back one, right? I just explained that whenever a service network VPC association is created, workloads in the consumer VPC access those services and resources through two different sets of non-routable IPv4 addresses. But this property of them being non-routable is very important, because if you have any workloads outside of that VPC, like an on-prem client or something that is literally outside of that single VPC, they cannot reach those services and resources in that service network, because those IPs are non-routable outside of that VPC. And also, if you want to combine more than one service network inside the same VPC, so if the consumers in the VPC want to access services and resources that are in more than one service network, you cannot use this pattern. If you remember at the beginning, I said that you cannot associate only one service network to any VPC. The last pattern sort of overcomes these two limitations. So on the right-hand side, nothing has really changed. The only difference is that now the consumer, instead of associating the service network to the VPC, creates a new type of VPC endpoint of type service network. And this is like it deploys ENIs in the subnets in your VPC, and it takes IP addresses that are from the VPC CIDR and therefore can be routable outside of that VPC, provided that that VPC has connectivity to and from it, right, with VPC peering, transit gateway, and other things.
And I would say,
ahead,
Nico, that there are like two ways we can look at that. So on one hand side, it's security-wise, you maybe want to have this feature that other VPCs cannot access the service network, right? On the other hand, of course, it's also a restriction, similar to transitive routing with VPC peering, right? It has ups and downs, so it's not strictly better or worse than the other, I would say.
Yeah.
What have you seen? Because I think what I'm seeing is kind of the rule of thumb becomes you probably want a VPC endpoint when you're connecting to a service network, and not the VPC association, right? That seems to be like if you're in doubt, start with the VPC endpoint. There's some additional functionality I think you guys are going to talk about in a second that comes with it. But other than you can connect to multiple service network from the same VPC, and then you can route from on-premise. If you want to limit it, you can put a security group around it and just curb it. I think the only potential downside is that there's IP addresses that you need to allocate to it, but like we were talking about, if you're not planning to route outside of the VPC, just get like a dummy range, or make it a V6 range, or make it a overlapping secondary side, or whatever you want. So I don't know if that's your view as well. If that's what you're seeing, that ultimately, when in doubt, endpoint is your friend, and then association you really have to have a reason for.
Yeah, I would +1 on that. So you should always default to service network endpoint. What many people don't know is that service network endpoints don't charge hourly. That they are different from PrivateLink endpoints. That's, I think, good to know, because price-wise, it's also the same as you're using association or service network endpoint.
Yeah, I think that's a good call out. We were chatting about it just before we jumped on the session. Right, that I see a lot of customers centralizing their AWS endpoints, right, where they have 100 VPCs with maybe 50 AWS services, CloudWatch, ECR, what have you. Those they have to pay for hourly. They normally want to centralize it. They put it in a central VPC as a transit gateway to get to it, but then they have to deal with DNS and all the routing. They could use Lattice as a way to expose those 50 AWS services, drop endpoints, just an individual endpoint for all services, as the service network endpoint. There's no hourly charge for it, so really doesn't much matter that you have one in each VPC, even if you're not using it, and then transferring data through it is not that much different. Than it's actually going to be less cost than transiting through transit gateway. So it's an interesting pattern that's coming up with the fact that the endpoint doesn't have an hourly charge here.
Definitely, I think that's a good idea for blog post, actually. Right.
Well, you wrote one already, Tom.
I think there's one already. I don't think we really spend that much time with. It's kind of like a side section, which we probably could have done at a bigger thing. But I'll try and find it and share it with folks here.
Okay, sorry, I might have missed it. But let's stay for a minute here on the service network endpoint. And again, we get a lot of questions in customer conversations around IP usage. You've already heard that the service network endpoint takes IPs from the local address range. And so the way this works in a bit more detail is that it has 1 to 2, the SNE gets 1 to 2 ENIs per subnet or AZ. And one it will always get, of course, and that is the services ENI. It will have one primary IP and a /28 delegated prefix for IPv4. And no matter how many services you add, it will not get more IPs, this first ENI. Now the second ENI gets deployed as soon as you attach the first resource to the service network. And then it will get one IP plus a /28 for the first 16 resources. And every additional resources will create an additional /28 on the ENI. So this means if you have a lot of resources, you also need a lot of space in the subnet that you put the service network endpoint. So basically one IP equals one resource here.
Yeah, we were talking about it also earlier about how we get a lot of people on internal messaging channels going, I can't create an endpoint. I have a /24 with 238 IP addresses left. And somehow, the first block is /28 of that /24 is reserved because AWS reserves some of the IP addresses in there. The last IP address is reserved. So if your edge blocks are gone, so in the middle, it's very likely that if you have a few interfaces dotted around, you might not actually have a clean /28 available. So if you're seeing errors when you're deploying the endpoints, just make sure, test it out in an empty /24 just to be 100% sure that the issue is not related to IP space.
I think the main takeaway of this episode is, rather than using VPC Lattice, is bloody use those secondary CIDR ranges on your VPCs because they're very useful.
Yeah. Get like a secondary CIDR range that's the same for all your VPCs and just use it everywhere for things that don't need to dock out of the VPC. Yeah.
And make it big, make it count.
Yeah, maybe this should be a more adopted pattern actually in the future. Right, and maybe one so that Alex doesn't hit us. One more remark. Again, you get a /80 for IPv6 per ENI, so there you are not running into this problem at all. And just maybe making the connection to the resource gateway. Remember that there you get just some IP addresses. They don't have to be from the same /28, right? They're just scattered across the subnet, so it's a bit easier to find space for those than it is with the service network endpoint.
Yeah, V6 is not an issue.
Correct.
There's one thing that just came to mind about using service network as a first option. I've had this a number of times with customers where they said, do you support service network endpoints cross-region? And the answer is no, we don't, as far as I'm aware, right? So you have to create a VPC endpoint in a certain region to make it accessible from other regions through things like Transit Gateway, cross-region peering, Cloud WAN. PrivateLink, you can do that, but not with VPC Lattice today. So
that's a good call out. Yeah, right now it's everything we're talking about is regional. So if you need to do cross-region, you need to facilitate that connectivity. Kind of like you used to have to do that with PrivateLink, right? Prior to us launching cross-region PrivateLink. If you wanted to consume an endpoint in another region, you have to create the endpoint and then set up your own routing there.
Right.
There's a question here, I think that's worth touching on from Karim, related to, does it matter if you have V6, V4 on one side, on the other side? Like, does Lattice help you with the translation between V4 and V6? So if you have your services at V6, will that still work?
Yeah, I think that's part of the beauty of the service. It does translate V4 to V6 and vice versa. So if you're a producer, you don't really care what the consumer has on the other side. For resources, maybe bear in mind that they have to be one or the other. So today you can't have dual stack resources. But the service network endpoints, the service network association, and the resource gateway all can be a dual stack.
Got it. Yeah. So I guess for resources, you're just deciding which one, even if you have dual stack, you're deciding which IP type you're going to focus on.
Yeah. Right. Yeah, maybe just briefly, I think this is a bit of a summary of what we touched already. So resource endpoints for one-to-one connections, they can be a good choice. Simple, quickly deployed. But as soon as you want like full mesh connectivity, basically every VPC should connect to every resource. That's the middle part here. Things get messy, and you're also paying for all the endpoints and all the VPCs. So this is where you are looking at then VPC Lattice, where you have, again, just one entry point into a service network, and then the service network has all the resources and all the services that you want to connect to.
Who wants to talk DNS?
Not me.
Let's get our audience to comment. Who wants to hear about DNS? Auth policies. I think there's a question coming from Ken about auth policies, and we touched on that earlier.
Yeah.
Right?
So yeah, on resources, no, right? Cool. DNS, but bear in mind, Nico, there's a little bit of a delay. So when you're asking questions on the chat, sometimes it feels like forever, because by the time you get an answer, it's a while. I think we want to hear about DNS.
I'll take that as a yes.
Yeah, we got let's go. Yes, finally.
Thank you. So in this diagram, we have something that we just explained earlier. It's the Service Network VPC Association model. You have a resource here on the right, a resource configuration that represents it, and then you share it with a consumer account. So consumer account has a service network, and that service network is associated to a consumer VPC. Now, whenever you associate a resource configuration to a service network, the VPC Lattice control plane allocates a publicly resolvable DNS name that is very long and very non-intuitive, right? I challenge any of you to memorize it and understand how it's put together. And that publicly resolvable DNS name resolves to an IPv4 and IPv6 address that come from those non-routable ranges that I talked about before. And before, I think it was November last year, when we introduced custom DNS, the way for if a consumer wanted to be able to use a bit more kind of humane and reasonable DNS names, they had to create a private hosted zone and an alias for this record, but you needed to obtain this through the APIs or the console for every resource, and it was a bit messy and complicated. And customers kept telling us, hey, please give us custom DNS. We want custom DNS, which is something we actually added last year, back end of last year, I think. And essentially what you have to do is when you create a resource configuration, you associate a custom domain to that resource, like in this case, myresource.example.com. And you optionally have to verify that domain. If you're familiar with the usual Route 53 domain verification, the process is very, very similar. So you have to add a TXT record to a public hosted zone to prove that you actually own, in this case, example.com. This step is optional, and I'll explain why it's optional. Then, if you want any consumer to be able to consume that resource using that custom domain, you have to do two things. You have to enable the enable DNS names parameter, make it true, both on the resource association, so the resource configuration association to the service network, and to the VPC association. I'm explaining this in the context of VPC associations, but the mechanics are exactly the same for service network endpoints and resource endpoints. So this has to be true if you want your consumer to be able to access the resource using this custom domain that you've configured. What happens under the hood is that the Lattice control plane creates a private hosted zone that is managed and you don't see, and it associates it to the consumer VPC. So whenever that association is created, that PHZ, that private hosted zone, is associated to the consumer VPC. As you can imagine, in an environment where the consumer doesn't trust your producer, you might want to enable only custom domains that are verified. So I want to make sure that the producer is actually entitled to use that domain, and they're not basically pretending to be someone they're not, right? So when you do a VPC association, or when you create a service network endpoint, you have the option of saying, I want a private hosted zone to be created for all domains, for verified domains, only for verified domains, and specified domains. Specified domains is essentially a list of domains that you can essentially allow list. Or only specified domains. So you're basically ignoring all the verification properties of said name. Okay, and this is very important. It's a security property that you might want to use. There's a very important use case, and Tom touched on that earlier, about centralizing AWS VPC interface endpoints. Obviously, if you're planning to use this model to centralize AWS VPC endpoints, you cannot verify AmazonAWS.com, right? Because you don't own it. Amazon owns it. So in that case, you either use specified domains only or all domains. But be aware that you cannot verify a domain unless you actually own it.
Yeah, I think there's a few questions here. Kind of one from TechField about verifying the domain ownership. So I think that pertains to kind of something you already a little bit covered, that if I don't own the domain and I don't verify it on the resource side, then the consumer has the ability to say, I don't want to accept any domains that haven't been verified. So there's like two sides of this coin, right? The producer can decide, I want to verify the domain or not verify the domain and use somebody else's domain, right? I could use that example.com I don't have to own. And when we don't own, I think somebody actually owns the example.com. But I could still use that as long as the consumer says, I'm okay with accepting unverified domains, right?
Yeah, precisely.
Okay. And then can you see, question here from Karim. Can you see the entries in that magical private hosted zone that gets created in the consumer VPC?
I don't remember.
Yeah, I don't think you can. I think that's all hidden away. There's no way to parse it. You just have to rely on looking at the association or the endpoint to figure out kind of what mappings have been done.
Yeah.
Okay.
Luca, the most important thing.
Of course, the most interesting part, pricing. So I think it's not overly complicated, but it's worth spending 2 minutes on it. So as we mentioned already, let's start with the consumer. The endpoints, they don't have hourly charges, but you're paying 1 cent per gigabyte to access resources in the service network. And on the other end, so if you now jump to the resource provider, where the resource gateway is deployed, you're paying these, it's 0.6 cents, right? 0.6 cents per gigabyte that's accessing your resource. So in total, you have 1.6 cents per gigabyte split across consumer and producer or provider, which can, of course, also be the same account, right? It doesn't have to be different accounts. And then when it comes to hourly charges, you are just paying the 10 cents per resource configuration associated with the service network per hour.
So if I have 10 resources, that's going to be $1 per hour, and that's it, regardless of how many consumers VPCs I have, right? So it's a model based on the resources you're associating rather than on how many consumers you have.
Correctly, yeah.
Yeah. And
So,
then I guess for comparison, the 1.6 cents, if we compare that to like Transit Gateway or Cloud One, I think that's a little bit cheaper than, and I'm assuming we're looking at like a European region or a region in US, right? Because pricing can vary depending on some of the regions. But if we compare it to Transit Gateway on Cloud One, I think that's a little bit cheaper than the processing data charges on TGW, for example, right?
yeah, right. There you have the 2 cents per gigabyte, right? So you're better off with Lattice here. And hourly, of course, you also have the attachments then for all the VPCs, which can be a large number if you have 100 consumers. Whereas here, you don't really care how many people consume the resources, right? You can have 1,000 consumer VPCs. The hourly price in the end just depends on the number of resources.
Yeah. I feel like sometimes when the hourly price is like something minuscule, I even avoid talking about it. Usually customers care more about the things that can be problematic with scale. So usually it's the per gig that most customers would care about. And then the hourly here, this even with Transit Gateway, the attachment is like $70 a month, if I remember correctly. So even that is not that much. And here, I think that model is even better with the hourly.
And also, I think it's worth calling out that most of the per gigabyte prices that we have here on the slides are tapered, right? So what we added here on the slide is the first tier, but the more you consume, I think these numbers go even lower, right?
Yeah,
if you go
I think
beyond, I think the first petabyte is 0.01, and then the price starts to decrease if that traffic starts to get bigger. And if any of our lovely attendees here think that they will, generate a lot of traffic or consume a lot of traffic, I encourage you to go on our public pricing page and see the details, right? If you want to have a more complete pictures on the per gigabyte price.
Cool. And just kind of a quick time check. I know we have 3 minutes left, so we're going to have to start wrapping up. I don't know if you guys have a final slide, closing thoughts.
Don't be scared. VPC Lattice is a lot simpler than you think.
Yeah. Have a play with it, right? That's I think like with you, if you're getting anything out of this session, have a play. Start with resources. I think it's so much fun when you see that, oh, I can just in any VPC override any destination of any domain if I accept the unverified domains. That it becomes extremely powerful.
And I think we have a number of very good samples on GitHub as well. If people want to get started with maybe some Terraform or CloudFormation code, it's fairly simple, and I think it really helps understanding the behavior of this service.
Yeah, I think if we don't have any additional slides, maybe we can take one more questions. I see here a question from Kareem. It's a little bit more involved, and it kind of mixing the Cloud One and Lattice together. I guess because you can be using both at the same time, right? You could be using Transit Gateway or Cloud One in parallel to Lattice, and anything that you push for Lattice will obviously have a slightly lower cost, and then it's just on an application by application basis. So it seems like the question is more about like how do you conceptualize that from a visibility point of view? How can you see kind of what's going where? And to me, I know I'm curious to see what you guys think. That service network container is giving you a very clear view of exactly what you're exposed. And then if something is not in the service network, then it will follow the routes or the paths that you've set up in Cloud One. So I have seen customers use Lattice and PrivateLink as a way to like kind of bypass some of the paths and inspection and just expose surgically different applications to one another. I don't know if you guys have seen the same, or what's your perspective here?
I would even argue that Lattice gives you a bit more visibility because you understand what is actually the destination of your traffic. It's not just an IP address that you see, right? You see it's maybe this or that service. And on Cloud WAN, you're just seeing IP source and IP destination. That's really it, right?
Yeah, agreed. It's much harder to audit. I feel like Lattice comes with this audit out of the gate. All right, I think we got like 20 seconds left, so I think we're going to say our goodbyes. Thank you, everyone, for joining. Nico, Luca, thank you so much for joining so late from Europe and sharing your thoughts with us. And see everybody next week on Wednesday. Thanks all.